Hey everybody, today we're going to talk about exponents and expressions. So this unit is about expressions. So an expression is different from an equation because an equation has this answer component. So we're just dealing with expressions for this unit. So there are three types of expressions. There's numerical expressions, word expressions, and algebraic expressions. So numerical are your expressions like 2 plus 5, they're numbers. Your word expressions are written out, so 2 plus 5. And then your algebraic include algebra, which we'll get to later. So today we're just focusing on numerical expressions. Those are the only ones we're looking at. So we're using exponents for those. So when I have a number like this, an expression like this rather, this part here we call the base, and then this little number up here we call the exponent. And the exponent tells us how many times we're going to multiply the base together. So in this case, I have 2/3 to the third power, or it can be read 2/3 cubed. So that looks like this. If I expand it into expanded form is spreading it out. Standard form is your answer. So then I would multiply 2/3 times 2/3 times 2/3. Remember, multiply numerators across the top, then multiply denominators for 8/27. The same thing would happen here if I had 3/4 to the fourth power. Now remember, these are in parentheses, and there's a reason for that. It's because I'm taking the whole 3/4 4 times. If I write it like this, that really means this. And that's not what I want. I don't want that. So it has to be in parentheses when I'm dealing with a fraction. When I expand it, I don't have to write it in parentheses, but when there's an exponent there, I need to write it in parentheses. So I would multiply this 3/4 together 4 times. 3 times 3 is 9, times 3 is 27, times 3 is 81. 4 times 4 is 16, and then times 4 for 256. I'm going to skip down here to a couple of strange ones. So here I have 0 to the 10th power. So 0 to the 10th power essentially is 0 multiplied together 10 times. So 0 multiplied together 10 times is just 0. So any base that is 0 will always have an answer of 0. Standard form will always be 0. Now this one's a little different. 5 to the 0 power. People want to say that this is 0 or it's 5, and it's actually not. And so I'm going to show you down here why that is. So I'm going to take 5 to the third, 5 to the second, 5 to the third, or 5 to the first, 5 to the 0 power, and we're going to look at some patterns here. So 5 to the third would be 5 times 5 times 5, and we know that that is 125. 5 to the second power would be 5 times 5, and that's just 25. 5 to the first would be 5, and that's 5. So if I look here at my pattern, what's happening, I'm losing a 5 every time, right? So that actually means I'm dividing a 5 out every time, which makes sense because if I do 125 divided by 5, I get 25. So then 25 divided by 5 gives me 5. So then 5 divided by 5 gives me 1. So any number to a 0 power, the answer is 1. So that would be the answer for that. Flipping over and writing my exponential form here, remember I need those parentheses and I have 3 of them. So it would be 1/2 to the third power, or 1/2 cubed. We say to the third power is cubed. To the second power we say squared. And so here for standard form, 1/8. Let's look at writing some in exponential form. So my base is always what I'm multiplying together. So that's my big number. And then I have 1, 2, 3, 4, 5, 7. So this would be 7 to the 5th power. Same thing here. I have 3 9s. 9 is my base. So 9 to the 3rd power. Down here, I have fractions, so I'm going to need parentheses. So 4/5. And I have 1, 2, 3 of those, plus 1/2. And I have 2 of those. So that's how I would write that in exponential form. And then last but not least, I have 4 13s. I don't need the parentheses around whole numbers. I can put them there if I want to. It wouldn't be wrong, but I don't need them. Minus, and I have 4 1/3. So again, I'll use my parentheses with an exponent of 4. And so that is how you evaluate numerical expressions.